So the object of today's video is to set up the new northern VYOS branch VYOS, which is that one there. Plus I've got a machine sitting behind it called Northern TC. TC stands for Tiny Core. That's a Unix sort of small format, small footprint operating system, so we can use that to test. Also, which I didn't show you last week, was this What's My IP server, which is 10.8.8.8. Basically it serves two functions. Firstly, it's a web server so that we can get out to something on our pretend internet, and also as well what it does is that when you actually go to it, it will read back your IP address that it's seeing you come in on. In this particular case, this laptop which I'm on at the moment is 192.168.1.100. So the first thing, so basically just think of it like this site here could be 500 miles away from the head office site. So we're going to just, I've sort of done a very basic configuration, just put on 10.0.8.2/30 on the Ethernet so that we can reach it. We're going in band, i.e. that means that the management control traffic will be using the same path in as the data. So it's going in by the internet. So we have to be very careful, because we could end ourselves locking ourselves out if we're not careful. Especially, you know, if you're putting in a firewall or something like that, you could end up just blocking yourself and you're not going to be able to get to it. So there's a feature in VYOS which I particularly like called commit, which allows you to put all the configurations in. Unlike other routers where you stick a configuration in and it immediately activates as soon as you put the command in. And say for instance you had a point-to-point link PPP and you changed it to a frame relay link, you know, say the ISP decided to change the format and you had to change it. 3 commands are required to bring a frame relay link up, and basically you can only stick one command in at a time, and as soon as you put the first command in, you're going to break the circuit and you won't be able to put the other 2 commands in. There's features on here which is very similar to Juniper, which allows you to actually put all the commands in, and they will not be implemented until you press the commit or type in commit. And you can also type in commit and with a 5-minute delay, just sort of say, I'll commit this change, but if something's gone wrong, it will, and you don't acknowledge that commit, it will refer back to its old configuration. So you don't end up getting locked out. I'll be showing you that shortly as well. So basically, I've set up the VYOS and I've delivered it on site. Got somebody to plug it into the WAN link. Got somebody to plug in the Ethernet into the other interface. So as you're going to see in a second, here's what we've got. So we've got our northern branch here. So if I do a show int, oh sorry, show int, you can see that I've already got the 10.0.8.2/30, and because I am actually coming in band, I can obviously reach that. Ethernet 1 is not configured yet. That will be the one where we'll have 192.168.8.0. The IP address that we're going to put on that is 254, and here I've got the core device. It's not configured at the moment, well it won't be configured with anything. As you can see, I look at the interface, there's no IP address, it just hasn't got anything, but it is connected to that LAN. So the first thing we're going to do is we're going to configure the second interface, Ethernet 1. So the way that you do that is you first of all go into configuration mode, and I'm going to set interface. If you've looked at my other videos, you'll be able to tell these. I run through these commands before, so I'm not going to run through them again. So it's Ethernet ETH1, and then I'm going to put an address on it, 192.168.8.254/24. So now I've got an interface is configured. So if I commit that, so I exit out and I'll just do a show int again. So as you can see, I've got 192.168.8.254. That doesn't help me at the moment because that other box will still not be able to connect, even though it's connected physically. We haven't set it up. And we're going to use DHCP. We're going to use the BIOS itself to hand a DHCP address to that server. So this is how you do it. So you just do set service, DHCP. As you can say, it's very intuitive. You put question mark in and it'll show us that what we want is server, and we want to make a shared network name. So we're going to call this, I'm just going to call it user LAN because that's what I called all the other ones. User LAN, and then subnet, subnet, and then question mark, and then you can have a look. So I want 192.168.8.0/24. That will immediately bind this to Ethernet 1 because we've already got an IP address in that range set. So also as well, I want to also set the subnet again, 192.192, and then we're going to put in the default router, and the default router for the PC to get to it will be 192.168.8.254. So we're going to set the actual interface itself on the VYOS as the default route for anything in that subnet. And now what we need to do is I need to set the range. We could set an actual static mapping where we can actually map the MAC address directly to an IP address. But in this particular case, I'm just going to put in start. So start, and I'm going to put 192.168.8. We'll start it at 10, and we'll finish it at 192.168.8.11. So we're just giving out two addresses. It'll pick up the first address. I would put in another device on that afterwards. I'll be showing against about NAT and PAT, but we're just at this particular point in time. I'm only going to put that in. So basically, we've now got enough to actually, if we commit that now, we have enough now for this guy to pick up an address. So if we go to this guy, and I'll get it. I'm just wondering if it would have picked it up straight away. There you go, it's picked it up. So it's picked up the first address now. You can see I go to 192.168.8.10. So it's picked up a DHCP address, and we should be able to ping 192.168. Oops, sorry. So we should be able to ping 192.168.8.254, which we can. Now see if we can actually get to that server. So I'm just opening up Firefox. It's a little bit slow because it's just a very small footprint image. Okay, so if I go HTTP, oops. Oh, come on. Probably need to put more RAM in it. Okay. 10. It's not happening. Okay, sorry about that. I went and rebooted the Northern Tiny Core client because it didn't have enough memory, so I put some more memory in it. It's working a lot better now. So basically, as you can see, at the moment there is no configuration on there at all. There's basically no IP address. So what we're going to do is we're going to set up the interface. So if I go and show interface, you can see that Ethernet 1, which is the one that's going to have our 192.168.8.254. So I'm going to put that on now. So go into conf mode. Not going to actually show you how this is done because you can see it in previous videos. So I'm just going to go and set interface Ethernet ETH1 address 192.168.8.254 and it's /24, and just going to commit that. So now I have an interface set up on there. We're going to be using the VYOS as a DHCP server, so I'm going to set that up. Oh, actually I'm going to set another interface, a loopback interface. I'm not going to actually give you the reason for this at the moment because it's going to be more relevant in future videos. So I'm just going to set this up quickly so that I don't forget. 10.0.8.5/32. Oops, it is. Right. Okay, so now I'm going to set up the DHCP server. So set service, so it's under the service command, DHCP, and it's a shared network, DHCP server, shared network name, yep, shared network name, and we're going to call this, I'm going to call it exactly the same as I put it on all the other ones, which will be user LAN. It requires a subnet, which subnet you're working with. Well, I'm actually going to be binding it to Ethernet 1, so it'll be subnet 192.168.8.0/24. And you can see with there's quite a lot of different parameters you can put in. You can actually, it's very configurable. We're not going to be doing that much in the way, but we basically need to make sure it's got a default router. So I'll put that in, and that's going to be 192.168.8.254. So it's using the Ethernet interface of the VYOS as its gateway. So I'm just going to set that, and then I'm going to set sorry, 192.168.8.0/24. I want to start from stock range. So basically, I'm going to just take the first 32 IP addresses in the bottom of the range. So I'm just going to make that start range 192.168. Start. So the starting IP address will be 192.168.8.1, and I'm going to just stop IP addresses from being served out at 192.168.8.31. And if I commit that, that's pretty much all you need to do to set it up. So it's about basic. Let's see if I haven't got one yet. Yeah, so let's check, make sure I've got. Oh, yeah, exit. Save the configuration. Always save your configuration, because even though you've committed it, if you was to reboot, you wouldn't have saved it to running, to the startup configuration. So if I exit out of there and I just do a show conf. Now there's two ways of doing show conf. You can just do a show conf like this, and it'll put it in the format very similar to Juniper. So as you can see, I've got shared network name, user LAN 192.168. So that's the subnet, default router, starting and stopping. That should be fine. Oh, okay, hang on, I might have to enable conf. You also, as well, you can do a show conf commands. If you do it that way, you see it as you would put it in. So as you can see, there's the set commands that I've been using. So in this particular case, if you go and have a look at, let's come down to, there's your DHCP server. So if I widen that up a little bit, do it again. So you can see 192.168. Okay, hang on. So if I go conf set service DHCP server, I think Should have been it. Wonder why I didn't. Oh, there you go. I probably didn't give it enough time. I saw it picked 192.168.8.10. It would have picked 192.168.8.1, but I actually just tested this before to make sure it was all okay. So it's obviously remembered that the 10, so it's using 10, which is fine. So now if I go and try and ping 192.168.8.254, change that. Ping 192.168.8.254. You can see it reads it okay. If I go and ping 10, don't forget we've got no firewall on this, so I should be able to reach the outside, the public IP address of the VYOS. If I go ping 10.0.8.2, which I can, and I can reach it. But if I try to do 1, which is the ISP, the service provider end, you'll see it won't go any further than that. And I certainly will not be able to ping the What's My IP server, because it will just not reach there. And the reason for that is because RFC 1918 addresses are not allowed to be propagated across the internet. So it gets dropped at the first hop. So it's not going to go any further than that. And in reality, you'd want your firewall to block it even at the firewall as well, stop it from going through. So that's great. So that's working fine. So, but that's not going to be any good to us because we can't go out to the internet. So we're going to need to do some more stuff. And basically what we need to do is we need to do NAT. So we're using port address translation. Like I said, port address translation maps outbound addresses. It does not map them in the other direction. So nobody, you're perfectly safe. You can only establish connections. NAT is different, but PAT, you can only establish connections on a mapping going out. So basically, you will be able to get up to the internet, but nobody from the internet will be able to get back into us because the NATing does not work in reverse. It's only in one direction only. So your established connections will go out, but nobody will be able to establish a connection coming back in. And pretty much that's basically all home internet. That's how it works. So you have your private IP addresses hidden from the outside world because the traffic gets natted from your private address spaces inside your network to the outside public address. So this is what we're going to set up in the VYOS now. So the commands to do that is set NAT, and because we're doing source NAT, because we want to change the source IP address to the public IP address on the outside, we need a source rule. So we're going to put source. You're going to put a rule number. I just use rule number. Rule. I think you can. It's a whole bunch you can use. So I'm going to use 10. So basically, we want to define our source IP address range. Well, in this particular case, we're using the first 32 addresses for our DHCP. So we might as well just use that first slash 32 with the 32 addresses, which is 192.168.8.0 because we're using the first subnet, and that's going to be a slash 28, I believe. I think 28. No, that's 16. So 27 actually will give you the first. They're the first 32 addresses. So basically, that's covered that. Okay, it says it's not valid. Okay, why is that? Oh, hang on. Address. Okay, now it's 192.168.8.0/27. Okay, now what we want to do is we need to tell the NAT what's our public outbound interface. Where are we natting to? What's going to be changed to? And basically, it's going to be our Ethernet 1. Oh, sorry, that's not. It's ETH0, isn't it? It's our public address. ETH0. And we need to then define the translation. Translation. Well, we're translating it to an address, of course. We're doing, but we are going to be using the outside. We can use the masquerade for this because what that masquerade is just hide. That's pretty much what it means. Okay, if we now commit that, that's all we need to do there. Now if I see if we can get to our 10.8.8, oops, 10.8.8.8. I already tried before. There you go. So the IP address that you're seeing there, even though we're 192, the box is 192.168.8.10, the IP address that the web server sees is the public IP address of the VYOS. So basically, you know, and if we tried to go back the other way, now let's say if I let me try and get to that 10.8.10.0.8.2. Let me just pull up a PuTTY session. So I go PuTTY, new session, 10.0.8.2. See, I'm on the VYOS. So I can't, even though, you know, the box is saying that's my IP address, I can't go back that way. I can't go back the other way. So if I just do, see, it's the VYOS. And if we just do a show NAT translation, I think, show IP NAT, I think it might be. Show NAT. So if I just do a show NAT translation, I think it's translation, oh, it's source. Translations. You can see there. That's the translation from that box to that box. And so that's pretty much it, really. I mean, not much more that I can tell you about that. That's pretty straightforward. So now we've got the box can reach the internet. The box is using the public IP address as its source, obviously. And now the next thing would be is to set it up for IPsec. No, what probably we do next is do the firewall rules so that we can lock it down, because at the moment it's not locked down. Right, I'm going to quickly sort of go through the reason why the commit command is so important. So we're going to be putting in, I'm going to be putting in a firewall rules, but what I'm going to do is I'm going to make the mistake of actually doing it incorrectly. So those of you who might be familiar with TCP IP tables would be familiar with incoming, outcoming, and local. So basically, in is obviously traffic that's coming into the in and through the VYOS. Out is obviously something that's coming through the VYOS and going out to the outside interface. And then there is a sort of local interface where the traffic is actually being directed to the VYOS itself. And obviously the local traffic will be important to us because we need to manage the VYOS, so we need to have a local rule. So I'm going to just use that local rule first. So basically what I'm going to do is I'm going to set firewall. So this is how to configure sort of firewall parameters. So I'm just going to put set firewall name. I'm going to call this internet allow VYOS. And basically this is going to be our rule that's going to be specified on the local, so the local interface. So basically, so it's going to be called internet allow VYOS. So internet, so anything from the internet allow VYOS, and the default action, obviously, for any sort of rules that you want to keep a tight firewall in, is you have to have a default action of drop. You never say it allow. So that's the default action. So default action, put that in, sorry, drop. Default drop, sorry, that's right the first time. So default drop, okay. And I'm gonna then forget to put, basically then you write rules then what you're going to accept after that. But basically we're just going to put in drop and you'll see what happens. So I'm going to set the interface. This is for it's coming on the outside interface. It's going to be Ethernet 0. So Ethernet ETH0, and the firewall rule that I'm going to apply. And like I said before, you've got 3 for inset or outside or local that's tested directly for the router. This is what we want. So firewall, and we're going to sort of say name, local, and the name of the firewall rule is the one that we've just done. It should be there. See, there it goes. Internet allow VYOS. Internet allow VYOS. Because we've not added any rules to this, specific rules to allow, it's going to just drop. So I could, this is where the commit confirm, this is where this becomes very important. Commit confirm, and we're going to say, I'll give it 2 minutes. Proceed, yes, confirm. Stuffed. I've locked myself out. I've locked myself out because the rule I put in there is denying everything. So I wouldn't be able to get to. This guy will still work. This guy will still be able to get out because, see, so if I put in another one, 10.8.8.8, you can still get out because it's not on the in or the out, it's only local to the VYOS. So what I've done is I've completely screwed my access up to the VYOS. So basically I've got to now wait 2 minutes, and this is the great thing about the confirm, because I know that in 2 minutes time I'll be able to go in and unlock. So that's the really, I mean, like I said, this router, we're pretending it's 500 miles away. So it's not exactly that you can get, somebody might not be technical enough to be able to reboot the router or shut it down and bring it back up. It might be on a VM server or something where they would not know how to get to it. So this is the reason why this is the reason why I love this commit command. See if I can restart the session now. No, it's not back yet, so I'll just give it a few more minutes. And like I said before, that's the great thing about this commit command. Okay, see if I can get into it now. Just do a duplicate session. No, okay, still waiting. Okay, we'll give it another minute or so. Don't worry about that, was from before. So no, it's not back yet. Maybe I should have just made it 1 minute. Okay, just okay, we're back. So we should be able to get to it now. There you go. So we've, so I'll just, okay, so if we do a show command, show conf command, you can see that there is no firewall configuration in there at all. So it reverted back to its old configuration, and I love that. I love that feature. It's a really good feature. I think I said earlier that when you apply a firewall rule, there's 3 ways you can apply a rule to an interface. So you can apply the rule so the policy affects traffic that's leaving the interface going out, so leaving the VYOS through that interface. That's called an out rule. You'd apply that as an out rule. You can also make the policy affect traffic that's actually coming in from an external to the VYOS itself or through the VYOS. So that's called an in rule. And you can also affect traffic that's coming in through an interface that's actually going to the device itself, and that's called a local rule. So we'll be giving you examples of all of those, obviously, as the video progresses or in future videos. But I want to show you something that may look a bit suicidal. Remember in our scenario that this BIOS is 500 miles away, so it's not like I can actually go and change anything if anything goes wrong. But I'm going to apply this rule, so the conf, and I'm going to set a firewall rule, and I'm going to call the name. We're going to be applying this on the outgoing interface of our internet, so ETH0 that's reaching the internet. So it's going to affect traffic, our traffic coming in as well, if we're not careful. So I'll set firewall name, and because we're sending it out to the internet, I'm just going to call it to internet. Internet allow. So if I put any rules in here, it will be associated with allow, but I'm going to set a default rule first. So I'm going to set firewall name internet allow default action. So if there is no rule, if the packet traverses all the rules and doesn't match any of the rules, it will do the default action, which is to drop. So, and also what I'm going to do is I'm not going to apply any rules. So basically this is going to drop everything. So I am now going to set this, rule. So set interface, and this is how you apply a rule to an interface. I want to be applying it to my ETH0, which is my internet, my one that we come in on. So I want to apply the firewall out rule. So this is going to affect traffic that's leaving the VYOS, and I'm going to put it name to internet allow. Now, because we've set everything to drop, everything that actually will come out that BIOS, or everything that's going to come out that Ethernet interface, when I commit this, we'll drop everything. So we're going to lose our connection, or we should lose our connection. So I'm going to use the confirm, because obviously I don't want to, I want to show you this as an example of why you need to commit confirm. And I'm going to commit it. Now that's strange. I've committed it, and it should be blocking the traffic, but it doesn't seem to be. Let's go and see if it actually is. So we're on the server behind the firewall. Go to what's my IP? Well, that appears not to, it's not getting through. So if I ping 10.8.8.8, no, I can't get that. I should be able to ping the inside because I didn't apply it to the inside. So just making sure that I can ping 168.8.254, and I can, but I can't ping out. So the rule is actually working, but I can still get in for some reason. So that is really strange. But actually, believe it or not, that is actually predictable behavior. That is what exactly it will do. And I'll need to explain to you why that is the case. So I'm going to show you a diagram now, because it's the easiest way to explain what's going on here. Even though I've got a firewall rule applied on the outgoing interface, which should be blocking everything, it's not actually blocking everything because you can still get to the device itself. So I'm going to explain that now. Yeah, that weirdness you were seeing is going to need some explanation. Obviously, we put a block all firewall rule on the external, but we could still get access to the VYOS, which in real terms you think you shouldn't have seen, but actually this is actually predicted behavior from the VYOS, and I'll explain why with this drawing. So basically I've represented the Ethernet 0 on the right hand side by 4 conveyor belts. Apologies for the poor picture, but anyway, so the data plane is the data that's going through the VYOS is represented by the blue conveyor belts. The traffic that's going to the control plane, which is the actual VYOS itself, is represented by the yellow conveyor belts. So there's a conveyor belt incoming for ETH0, which is bottom right, and a conveyor belt for external, for traffic that's outgoing, or egress traffic going out of ETH0, represented by the conveyor belt as the top right. Traffic that's leaving Ethernet 1 is represented by the bottom left blue conveyor belt, and traffic that's entering ETH1 is represented by the conveyor belt on the top left. So basically we're looking at it as a representation of router only, so we're just pretending this is just a router and there is no firewall and there's no NAT or anything else like that. So this is the way that the traffic would flow when the device is acting like a normal router. So the packets that are going through the VYOS, so there's nothing going to the VYOS, going through the VYOS is represented in this picture. So basically the brown packets are representing the traffic that's going through the VYOS, and as you can see, it's entering ETH0 from the internet, going straight through incoming conveyor belt, across the bottom, and outgoing through Ethernet 1. Any return traffic that's coming the other way will be represented by the packets on the top left, enters the conveyor belt, goes into the direction of the arrows, and then goes out via ETH0. At this point in time, no traffic has been defined to go to the VYOS yet. So the next picture is going to represent the traffic, not only data plane traffic going through the VYOS, but some traffic that is going to the VYOS. Say we're doing an SSH to VYOS. These packets are represented by green packets. So as you can see, as soon as the traffic, so I'm outside coming to SSH to the VYOS from the internet, my packets hit the bottom right conveyor belt and is immediately seen by the little fellow there and pulled off the conveyor belt and put onto a separate conveyor belt, which is the yellow conveyor belt, which sends it to the VYOS control plane. Control plane then goes and processes the traffic, and any return traffic would go up by the top right, as you can see, onto that top right yellow conveyor belt, which is being watched by somebody, and that person will then drop the traffic back onto the control plane and out the Ethernet interface back towards the internet. Note that the VYOS traffic is exclusive to the interface it's going in on, so there's no chance of the traffic coming in on ETH0, well, at least I don't think there is. I don't know if there's a scenario that there would be, but there's no real reason for the traffic that's coming in via ETH0 going up to the VYOS would get ever passed across the VYOS and go down ETH1, out of ETH1. That just doesn't work that way. So this is pretty much it. So, but it doesn't answer the question yet about why the firewall didn't block it. Well, it's the reason why it doesn't block it is because of the position of the firewall. So this is the point. At this particular point, I'm just looking at the external interfaces here because we were doing an outbound firewall rule. As you can see, that the traffic coming into the device will be unaffected because there's no firewall on the incoming interface anyway. But look at the outgoing interface, the top right. You can see that the packets for the VYOS actually completely bypass the firewall. They get dropped onto the control plane conveyor belt after the firewall has even the firewall never even sees the packet, and that's the reason why, and that doesn't see the packet either, and that's the reason why these particular packets that are going into the VYOS and out of the VYOS do not get affected. I mean, obviously the traffic that's coming in from Ethernet 1, from our server, obviously it's got to get to the firewall processes it before it can leave, so that's the reason why they can't get through. But the reason why you can get to the VYOS is because it's not processed. It never gets processed by the firewall. So hopefully this is hope it makes sense. It's the easiest way I can explain it. It's not an explanation for everything, but it sort of explains this quite well. So hopefully you understand it. So now you understand that obviously blocking these rules, you have to do it very carefully. You've got to be aware about how the actual device is actually, the traffic's flowing through the VYOSes in order to be able to understand how to apply the rules. So really, you can't block any traffic going to the VYOS, not through the interface Ethernet ins and outs. So your full control of the VYOS is actually via the local. So you will have to apply a local filter to ensure that your VYOS is protected from all sorts of traffic. And so we're going to be applying 3 rules now. So we're going to be applying an in rule because we want to actually stop some traffic going through. We certainly don't want established initiated sessions to try and get in, even though we're using that, and even though it's port address translation, which is protecting everything, we still want to make sure that the firewall is ensuring that there's no way that the firewall is going to allow stuff coming inside. We're also going to apply a local rule because we want to protect the VYOS itself. And we will be applying an outbound rule to restrict what the server on the inside can reach from the outside. So we're going to be applying 3 rules. So the first rule that we're going to apply is we're going to allow internet access into the device. Of course, we want our management network to get in, but we don't want nothing else coming in. So these are the rules that we're going to be setting. I've already to put them down in order, so I'll just do them one at a time, and I'll explain them as I go. So this is the first one. Let's widen it a little bit. So basically, this is the name of the firewall rule that's going to be coming in from the internet, that's going to be accessing VYOS. And so what we want to do with this one is obviously anything that doesn't match any rule will be dropped. So this is why we got our default action. So then now we apply our specific rules. Okay, so this is the first rule. You can start from 1, you can go up to 9,000 or something like that. It's a big number. I'm going to start at 10, and we want this action to accept. So any rule, any parameter that matches this rule number, will accept it. So the first thing we want to do is we want to allow TCP on from our management network, which is this guy. So 192.168.1.0, that's our management network, and we want to allow that. And we want to allow SSH, which is port 22. That is it. So basically what we've said there is we want to allow TCP protocol from 192.168.1.0 on port 22. If you want to allow HTTP, for instance, as well, you can't add HTTP to this rule 10. What will happen is the rule HTTP will override port 22. So you have to put each one on its own. So if you wanted HTTP from the same one, you'd say rule 11, source address 192.168.0.24.1.0, protocol TCP, destination port 80 or 443 or whatever you're going to do. So that is it. So what we're doing there is we're saying this rule, when applied, depending on where it's going to apply, will allow 192.168.1.0 to come in on port 20 with destination port 22, which is SSH. We want a second rule now to be applied to the same policy. So this I made rule 20, and obviously this is accept. So we're going to accept whatever parameters are following to be allowed. So I am going to allow obviously our management network again, and we're going to allow ICMP, and I want to just allow echo requests, so sort of ping requests to come in. Okay, and we will set the rule action to accept. Sorry, that's it. Sorry, that will be it. So, okay, so we've got our rules. So basically what we said, internet access VYOS allow. So we want this to be applied to traffic that's coming, well, it's going to be coming from the internet. So we're going to be applying this on Ethernet 0. But we're going to be applying it as a local rule because it's only the traffic that goes to the VYOS. So this is how we set it. So set firewall name. No, sorry, interface. Sorry, set interface. We want to apply this on our Ethernet interface, so it will be ETH0 and firewall name firewall local. Sorry, it's local. We're applying it to, and the name of the rule that we want to apply to the local interface is our internet VYOS allow. So we should be able to safely commit this. So I'm just going to commit this. And as you can see, it's fine. I don't have any issues. And I'm going to save this because we're going to keep this permanently. So obviously I can get in via SSH because I'm already there. And if I do a ping, so if I open up a command, I'm on the 192.168 network. So if I do a command, I should still be able to ping. So ping 10.0.8.2, which I can. Okay, let's find out if we can actually get it from another. So this is another one this is another device that's sitting out on the internet. So, but this has not got a 192.168 network. So let's see if I can ping that IP address, 10.0.8.2. And I can't. And if I try to do an SSH, VYOS at 10.0.8.2, I can't do that either. But let's go to our other box, which is on the other side, on the inside. Because we're only affecting the VYOS, we can get to our what's IP server because it's local and it's only affecting the outside interface, so it's not affecting anything else. 8.10.8.8.8. Yep, see, I can still reach it. And let's see if I can actually reach the VYOS. Ping 192.168. So I'm going to go to the firewall's Ethernet 1 interface, 8.254. I can reach it. And I should be able to reach the VYOS on SSH as well at VYOS SSH VYOS at 192.168.8.254. See, I can reach that. And see, I'm on the Northern Branch VYOS. And of course, but we don't want them to be able to reach that. We want them to be able to go through and get their stuff, but we really don't want any users on our network, even though they're local users. We don't, we're managing this service for them, so we don't want them on the network. We don't want them to be able to access the VYOSes in any way or form. So the next rule we're going to do is we are going to kick them off. But still allow them to get through to their stuff. So we have another rule, and this rule is going to be, we're going to again apply this as a local rule, but we're going to be applying this as a local rule on the Ethernet 1 interface. So this firewall rule is just to prevent anybody from trying to come onto the VYOS. We're going to allow them to ping, but we're not going to allow them to do anything else. So this one is going to be called user, because we're on the user LAN VYOS allow. And this rule, we're going to make the default action as drop. So if it doesn't match any of the rules that we're going to put into this when, it's just going to drop it. And we're going to set the firewall rule name rule 10. 10. So what do we say? We're only going to be accepting ping only. Rule 10 action accept. So we're going to accept this particular rule, and we're going to make it. We're only going to allow the source address. Rule 10 source address, and our address range is only from 192.168.8.1 through to 192.168.8.31. So we're just going to allow the 192.168.8.0/27, which will allow all those addresses, but nobody else. And we're going to allow the protocol ICMP and the ICMP type echo request. ICMP type ICMP type name, type name echo request. You can have echo request or reply. That's the reason why I didn't fill out to complete the thing. And pretty much that's it. So we will now apply that. So we'll set interface Ethernet ETH1, and it's going to be a firewall rule applied, and it's going to be a local firewall rule because it's going to the VYOS name user LAN allow, and commit. And save that as well. Now we should be able to, so let's just make sure that we can go straight through still. So go to our server, what's my IP? Yeah, we still can go through. We can ping. We should be able to ping 192.168.8.254, and we can. But now, can we SSH? No, we can't. So that's that rule in action. So basically, you've got to remember that anything that's going to the VYOS, the only place that you can actually apply a policy to make sure that nothing can get to the VYOS is on the local, so the firewall local rule. Okay, so so now what we've got is pretty much we've got control over what we want to send through. I mean, I will put all the other rules in, and I'm literally just going to put them in as I see them. So really you want to be nailing down the VYOS with the local rules from all your interfaces, not just the outside one, but any other interfaces as well. You want to be applying through rules, so out, going out, and in, coming in. So I'm just going to apply these. I'm going to cut and paste these, and I'll just leave them up so that you can see them and you can copy what I wanted to do. So we've already got the rule that's allowing access in from the internet. We've also got the rule that's preventing the LAN, anything on the LAN to access the BIOS. We've got one more rule that we need to set pretty much, and this rule I'm going to actually just cut and paste in, and I'll explain each line as it goes. So this is to the internet allow. So basically, you remember the internet allow doesn't work for the VYOS, so we've pretty much got to remember to add the local rules to make sure that's how we control access to the VYOS. So what we've got on what we want to allow out to the internet is we want to allow port 80 to go out, and so anything that's going to port 80 or port 443, so that's your www and your HTTPS, and an echo request to go out So basically we're just allowing ping, so we're allowing pretty much the server behind us to be able to go out on 443 and go out on 80 and are able to ping just to verify. So they're just basic rules, but I'm just showing you how you harden it. So so now we just need to set this rule, obviously. So we're going to set it to the interface, and the interface we're going to set it to is ETH0 again. And basically it's out, sorry, firewall, sorry, interface ETH0, oh, Ethernet ETH0, firewall, out, and name to internet, allow, commit. So now we have got, so we've locked it down pretty much. So this guy will still, so this guy won't be able to SSH out. He will be able to ping because we've allowed that rule out. 10.8.8, 10. Yeah, 8.8.8. Oops, spell it correctly. And we've allowed, obviously, HTTPS and HTTP, so we'll still be able to get to his 8.8.8, still be able to get to that server. So that's pretty much it. So this is what I wanted to do just for this video. Obviously, your firewall rules will be more complex than this. This is just basically just giving it, hardening it to a level so that we can sort of use it, and then you apply rules on top of that, you know, when you find fit. So yeah, so for the next video I'll be going through setting up VPN, site-to-site VPN. And again, you have to be careful because you've got to remember where in the chain the site-to-site VPN is actually enabled. You've got to remember that site-to-site traffic that's actually got to be going out of the Ethernet ETH0 interface before the process of VPN encrypting it will happen. But again, you've got to remember where is it, where does VPN lie in the process string, as it were, the chain. Does the firewall happen before the VPN, or does the VPN happen before the NAT? So these things you've got to sort of work out, and I'll be going through that in the next video. Thanks for watching.